Has the James Webb Telescope just caught a glimpse of an alien civilization? The James Webb Space Telescope may have just spotted something extraordinary, lights that look eerily similar to those found in cities here on Earth. What's even more astonishing is where they were seen, coming from a point nearly 7 trillion miles away. This strange glow was detected near Proxima Centauri b, the closest known exoplanet outside our solar system. Naturally, the big question follows: are we witnessing signs of life? Let's take a closer look at how this powerful telescope stumbled upon a finding that could redefine our place in the universe. For years, scientists and dreamers alike have searched the skies for any hint that we're not alone. Even the tiniest clue was enough to ignite imaginations. But now, we may have something more concrete. While observing the vast reaches of space, the James Webb Telescope picked up something unusual on Proxima Centauri b, bright patterns of light resembling cityscapes. The implication? Possibly an alien civilization lighting up the night. The discovery has stirred excitement across the scientific world. Could intelligent life really be thriving somewhere out there, shaping their world in ways we're only beginning to imagine? NASA engineers are stunned. These mysterious lights have possibly been shining all along, hidden in the darkness, waiting for us to develop the technology to notice them. And now, thanks to Webb's unmatched infrared sensitivity, we finally can. Columbia University astronomer David Kipping called Proxima b a particularly unusual planet. Unlike typical rocky worlds that soak up sunlight and emit infrared radiation evenly, Proxima b behaves in an unexpected way, largely due to its unique connection with its parent star, Proxima Centauri. This makes the discovery even more exciting. Webb's ability to read infrared wavelengths was critical in detecting Proxima b's unusual thermal fingerprint, offering a deeper glimpse into its possible atmosphere and conditions for life. What sets the James Webb Telescope apart is its ability to spot even the faintest glimmers of light in the vast blackness of space. That includes artificial light, if it exists. Its precision allows it to pick up narrow frequency bands that might just reveal the glow of a technologically advanced world. Proxima b has an interesting day-night cycle caused by its orbit around its faint red star. The day side, possibly lined with solar panels, gathers energy while the night side cools down. If Proxima b lacks an atmosphere, temperatures would swing dramatically, blazing heat by day and freezing cold by night. Understanding this temperature difference gives researchers critical insights into whether Proxima b has the kind of atmosphere that could shelter life. Thanks to its unmatched infrared imaging, the Webb telescope can track these heat patterns and analyze the planet's climate in detail. Interestingly, the telescope's orbit aligns with Proxima b's own orbital period, about 11.2 Earth days, allowing scientists to observe full rotations of light and shadow on the planet. If an atmosphere is indeed present, the next step is to study its chemistry for signs of habitability. Could oxygen, water vapor, or even traces of methane be hiding in that atmosphere? If so, this distant world might not just be habitable, it might already be inhabited. Are we on the brink of discovering life beyond Earth? Imagine a planet light years away, its atmosphere whispering secrets in the form of gases, oxygen, water vapor, methane. If these elements are found, it could mean one thing: the conditions for life are there, but uncovering such clues is no easy feat. Scientists need to capture light as it passes through a planet's atmosphere, light that may carry hidden messages about habitability. It's a delicate, complex process, and while the James Webb Space Telescope, JWST, is one of the most powerful tools we have, it's not built specifically for this job. Even so, JWST excels at analyzing atmospheric gases like carbon dioxide, methane, and water vapor. While detecting oxygen is trickier, especially when it's chemically bonded, the telescope can search for other vital compounds, like ozone, which often signals the presence of a stable, breathable atmosphere. Every new clue from Webb pushes the search further. But it's worth noting that Webb has a limited reach. It can only investigate a handful of the closest potentially habitable worlds. To go deeper, scientists are looking to the future. Telescopes like the Extremely Large Telescope, ELT, scheduled to begin operations in 2028, promise even sharper views of distant planetary atmospheres. With cutting-edge technology, the ELT will help us dissect the structure and chemistry of exoplanets in remarkable detail. And there's more coming. Researchers are designing next-gen telescopes to block the blinding light of stars, just like shading your eyes from the sun, so we can finally see the planets orbiting around them. These clearer views will make it easier to detect the faint glow reflecting from a planet's surface and analyze what's in its atmosphere. But there's a twist. Scientists must also learn to tell the difference between gases produced by living organisms and those created by natural processes like volcanic eruptions. It's a fine line, and getting it right is crucial if we want to avoid mistaking nature's handiwork for alien life. That's why astronomers are so committed. They want to go beyond curiosity and get real answers. The James Webb Space Telescope is giving us an exciting glimpse into that future. Though it has its limits, it's already revealing things we never imagined, from puzzling planetary lights to mysterious mass hiding in distant galaxies. For thousands of years, humans have asked one of the biggest questions: are we alone? Today, thanks to tools like JWST, we're closer than ever to finding out. This same question inspired astronomers Jill Tarter and Thomas Pearson to launch the SETI project back in 1984. They built a non-profit dedicated to listening for radio signals from space, since radio waves can travel massive distances without getting lost. Their instrument of choice: the Allen Telescope Array, nestled in the California mountains, made up of 42 powerful radio dishes. Over 30 years have passed, and SETI hasn't yet picked up a definitive alien signal, but Jill Tarter remains hopeful. She believes the right technology could finally bring answers, and that every person on Earth can play a role in this grand cosmic search. Now, with James Webb orbiting nearly 1 million miles from Earth, the search has entered a bold new chapter. This powerful telescope is bringing back detailed data about the oldest stars, galaxies, and perhaps new signs of life. Equipped with ultra-sensitive cameras and filters, JWST is designed to detect subtle patterns in light, helping scientists decode the physical and chemical makeup of far-off worlds. It can even pick up tiny hints of life hiding in the atmospheres of planets we've never seen up close. And the discoveries are already piling up, from surprising amounts of hidden galactic mass to mysterious city-like lights on exoplanets like Proxima b. Each revelation challenges what we thought we knew about the universe and inspires us to keep looking. The James Webb Space Telescope isn't just watching the stars. It's reaching across time and distance, opening new doors in the search for life and helping us understand how everything, from galaxies to civilizations, might come to be. As we explore deeper than ever before, we move one step closer to answering the age-old question: are we truly alone in this vast cosmos? Or have we just begun to hear the whispers of another world? Just 2 decades ago, planets beyond our solar system were mostly science fiction. Now, we've discovered over 4,000 of them, each one a reminder of how far our curiosity and technology can take us. NASA believes this is just the beginning. According to scientists, there could be trillions of exoplanets still out there waiting to be uncovered. And with every new find, the dream of discovering alien life feels a little less like fantasy. Sometimes that dream comes close to reality. When the Galileo spacecraft flew past Jupiter, it accidentally detected a strange signal, a clue that might point to plant life. This unexpected find revealed what's called a biosignature, specifically something known as the Vegetation Red Edge, or VRE. It's a unique way of detecting life by analyzing how light reflects off certain surfaces. Now, with powerful tools like the James Webb Space Telescope, JWST, scientists are searching for these subtle signatures in faraway worlds, scanning for planets in the Goldilocks zone, where conditions might be just right for life to take root. If VRE-like indicators show up, it could shift everything, offering solid leads that intelligent life exists beyond Earth. It would mark the start of a bold new chapter in our exploration of the universe. Here's how it works. Starlight filters through a planet's atmosphere and gets absorbed and scattered by molecules along the way. This interaction leaves behind a spectral fingerprint, a kind of cosmic ID tag. Using a technique called spectroscopy, astronomers can decode this fingerprint to reveal what the atmosphere is made of. JWST is perfect for this. It's designed to catch those tiny hints of starlight that sneak through a planet's atmosphere. If it finds the right chemical mix, like carbon dioxide, nitrogen, and oxygen, it could suggest the planet is suitable for life. But scientists aren't just looking for familiar ingredients, they're also on the lookout for the unusual. Take chlorofluorocarbons CFCs, for example, man-made chemicals used in refrigerators and industry. If JWST ever detected these on a distant planet, it could be a smoking gun, proof that intelligent beings are out there, altering their environment just like we do. That kind of discovery would expand the possibilities astronomers explore and open the door to studying entirely new kinds of alien worlds, maybe even civilizations beyond our galaxy. When we think of life, we tend to picture Earth-like environments, blue skies, liquid water, mild temperatures. But the universe might surprise us. Just look at extremophiles, hardy microbes on Earth that thrive where most life can't. They live in boiling acid, endure radiation, and survive at temperatures that would destroy other organisms. If life can exist in those extremes here, who's to say what might survive out there? As scientists cast a wider net in their search for life, they're considering planets that don't look or feel like Earth. That includes those orbiting red dwarf stars which are cooler and dimmer than our Sun, but incredibly common and long-lived. These stars might give life more time to evolve. A prime example is the TRAPPIST-1 system. Located about 41 light-years away in the constellation Leo, this system has 7 rocky planets, 3 of which sit comfortably in the habitable zone. Though the TRAPPIST-1 star is smaller and cooler than our Sun, it still emits enough light to warm its planets and possibly sustain life. Thanks to the James Webb Telescope, scientists are analyzing the light from this system, searching for chemical signs in the planet's atmospheres that could hint at something living there. Ward Howard, a NASA Sagan Fellow and lead scientist at the University of Colorado Boulder, could barely contain his excitement. Thanks to the James Webb Space Telescope, JWST, he explained, we now have an unprecedented ability to detect planets around other stars that may have secondary atmospheres, similar to Earth's. Understanding the stars themselves, he emphasized, is key to truly unlocking the secrets of the planets that orbit them. One star in particular has grabbed global attention, Proxima Centauri, our closest stellar neighbor, just 4.25 light-years away. It's a faint red dwarf, barely visible in our night sky, but it may hold the key to one of the biggest questions humanity has ever asked. Are we alone? Because Proxima Centauri gives off far less light than our Sun, any potentially habitable planets would need to huddle much closer to stay warm enough to support life. And on August the 24th, 2016, astronomers discovered just such a planet. Proxima b, a rocky world roughly 1.3 times the mass of Earth, orbiting right in the star's habitable zone. That means it's at just the right distance to allow liquid water to exist, an essential ingredient for life. Proxima b is tucked in close, only about 4.66 million miles from its star, compared to Earth's 93 million miles from the Sun. But being that close comes with serious risks. Powerful solar winds from Proxima Centauri could strip the planet's atmosphere away, making it harder for life to survive. Even so, this little planet still gets enough warmth to keep water from freezing, which is a major plus in the search for life-friendly worlds. There's another twist. Proxima b is likely tidally locked. That means the same side always faces the star, bathing one half of the planet in endless daylight, while the other half is trapped in permanent darkness. It's a bit like how the moon always shows the same face to Earth. This extreme contrast between the light and dark sides might create harsh living conditions. but it also opens up fascinating possibilities. Could life adapt to the twilight zone, the narrow strip between scorching day and frozen night? Despite its dim glow, Proxima Centauri still gives off enough energy to spark the possibility of life as we know it. And with JWST scanning the skies, we might be closer than ever to answering a question that's echoed through the ages. Could those strange flickering lights observed on Proxima b be signs of an advanced civilization? Or is there another, more natural explanation waiting to be uncovered? What do you think? Drop your theories in the comments. And if this kind of cosmic mystery fascinates you, be sure to like, share, and subscribe for more journeys into the unknown.